Assalamu alaikum, this is Tuqa Damush. In today's period we are going to solve exercises related to the position of the element in the periodic table. So please get your pen and your chemistry booklet. First of all, let's make a quick revision over what we have studied in the previous session concerning the characteristics of the periodic table. Elements in columns 1, 2, 13 till 18 are called main group elements. Elements in columns 3 till 12 are called transition elements. Elements in column 1 belong to group 1 and they are called alkali metals. Elements in column 2 belong to group 2 and they are called alkaline earth metals. Elements in column 13 belong to group 3. Elements in column 14 belong to group 4. Elements in column 15 belong to group 5. Elements in column 16 belong to group 6. Elements in column 17 belong to group 7 and they are called halogens. Elements in column 18 belong to group 8 and they are called noble gases, rare gases or inert gases. The elements that are separated out of the table are called inner transition elements. The elements that belong to period 6 are called lanthanides and those that belong to period 7 are called actinides. The electron configurations of the elements in column 1 end by S1, while the electron configurations of the elements in column 2 end by S2. These elements constitute the S block. The electron configurations of the elements in columns 3 till 12 end by D1 till D10 respectively. These elements constitute the D block. The electron configurations of the elements in columns 13 till 18 end by P1 till P6 respectively. These elements constitute the P block, except helium, which belongs to the S block since its electron configuration ends by S2. The electron configurations of lanthanides end by 4F, and that of actinides, they end by 5F. These elements constitute the F block. Now it's time to master what we've learned. Determine the atomic number Z in each of the following cases: the element located after NO in the periodic table, the third alkali metal, the second halogen, third transition element, fifth actinide, and finally the element located below Zn in the periodic table. Pause the video and assign 5 minutes for each part to solve it. Let's start with the first part. Determine the atomic number of the element located after NO in the periodic table. As you can see, you are given the atomic number of NO, which is 102. So the element after NO has an atomic number of 102 plus 1, which is equal to 103. Since elements in the periodic table are arranged in increasing order of their atomic number Z. So whenever you are asked to determine the atomic number of an element located after another element with known atomic number, let's take as an example NO, just add 1 to the atomic number of NO and subtract 1 from the atomic number of NO if you are asked to determine the atomic number of an element located before NO in the periodic table. Now move to the second part. Determine the atomic number of the third alkali metal. Just pay attention to the idea that you have to keep in your minds the shape of the periodic table and not its content. This means that you have to remember, for example, that alkali metals start from row 2, since hydrogen, which is the first element, is a non-metal, and therefore the third alkali metal is in row 4, so it has 4 energy levels. Also, alkali metals are in a group 1 or column 1, so their electron configurations end by S1. Now using Klischkowski diagram, we'll write the electron configuration till we reach row 4, which must be the highest energy level. Then we'll end this configuration by S1. So the electron configuration is 1s2, 2s2, 2p6, 3s2, we can't stop, still we are in row 3, so 3p6, and finally 4s1. In this case, we reached row 4 since the highest energy level is 4, and column 1 since the electron configuration ends by S1. Now the number of electrons is equal to the sum of the electrons on the sublevel, which is equal to 19. As usual, the number of electrons is equal to the number of protons in a neutral atom, and the number of protons is equal to the atomic number Z, and therefore atomic number Z is equal to 19. Just remember that alkali metals start from row 2 since hydrogen is a non-metal. Now determine the atomic number of the second halogen. From the shape of the periodic table, remember that halogens start from row 2. So the second halogen is in row 3 and thus it has 3 energy levels. Also, you must know that halogens are elements in a group 7 or column 17. So the element belongs to block P and hence its electron configuration must end by P5. Now the electron configuration is 1s2, 2s2, 2p6, 3s2. As you can see, we reached row 3, but we must continue until the electron configuration ends by P5. So finally 3p5. In this case, we reached row 3 and column 17 since the electron configuration ends by P5. Now number of electrons is equal to 17 and therefore the atomic number of the element is 17. To sum up, in order to solve such application, you have to remember that halogens are elements of column 17 and the first halogen starts from row 2. Here pay attention to this part. Determine the atomic number of the third transition element. As mentioned previously, let the shape of the periodic table in your minds, so you can know that the transition elements start from row 4. So the first transition element till the 10th transition element are in row 4, and therefore the third transition element is in row 4. And as you know, transition elements start from columns 3 till 12. So the first transition element is in column 3. The second transition element is in column 4. And thus the third transition element is in column 5. And since the transition elements are in block D, so the electron configuration of the third transition element must end by D3. Now the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. As you can see, we reached row 4, but we'll continue until the electron configuration ends by D3. So finally 3d3. So the number of electrons is equal to 23 and therefore the atomic number of the element is 23. Remember that transition elements start from row 4. And as we said previously, the first transition element is in row 4 till the 10th transition element. Now determine the atomic number of the fifth actinide. It's known that actinides belong to row 6, so the highest energy level is 6. In general, the electron configurations of actinides end by 4f, so the electron configuration of the fifth actinide must end by 4f5. As usual, we write the electron configuration till we reach row 6 as a first condition, and then we'll end this electron configuration by 4f5. And here is the corresponding electron configuration of the fifth actinide. So the number of electrons is equal to 93, and therefore the atomic number is equal to 93. Now let's summarize that using this section of the periodic table. The electron configurations of all actinides end by 4f. So the electron configuration of the first actinide ends by 4f1. The second actinide ends by 4f2, and so on. So the electron configuration of the fifth actinide ends by 4f5. Finally, determine the atomic number of the element located below Zn. Let X be the element located below Zn. From the atomic number of Zn, which is equal to 30, we'll write the electron configuration of Zn, which is as follows. As you can see, Zn is in row 4 since it has 4 energy levels. So X is in row 5 since it's directly below Zn. Also, Zn is in column 12 since its electron configuration ends by D10. As a result, X is in the same column of Zn, so its electron configuration must end by D10. Now the electron configuration of X is 1s2, 2s2, 2p6, 3s2. We'll continue till we reach row 5. So 3p6, 4s2, 3d10, 4p6, 5s2. We reached row 5. We'll continue until the electron configuration ends by D10. So finally 4d10. Briefly, number of electrons equal to 48, so the atomic number of this element is equal to 48. Now it's time to assign the homework. Please watch the video again and copy the 6 parts of this application on your chemistry copybook, and finally solve the exercises in worksheet 5 of your chemistry booklet.